primary purpose of an MSE structure is to solve grade separation problems on site that are either geometric or have right-of-way issues, unfavorable soil conditions, or other environmental constraints. They can be designed to withstand the lateral earth pressures and other external forces such as live and dead loads. With the constant need for property development and the rapid increase in land cost, resolving these grade separation challenges for a more usable space has become increasingly necessary. MSE walls and slopes are cost-effective. They're typically easy to construct, can tolerate large settlements, and are rugged and durable. They can be constructed quickly and efficiently, which is particularly important with time-sensitive projects. They are considered sustainable vegetated wall systems that are environmentally friendly and can be designed to blend in with the surrounding landscape. We've seen an increase in engineers specifying these vegetated slope systems to provide more greenery and help reduce superficial runoff versus traditional concrete retaining walls. This is becoming more important with just the increased urbanization through many of the metropolitan cities here in Toronto and some of the other larger cities in Canada. Just to clarify, what we're talking about is conventional retaining walls, which are cantilever or gravity walls made of concrete and steel. As concrete walls increase in height, lateral earth pressures increase, bending moment at the base also increases. This exponentially increases the material used to resist these loads. So MSE walls are, again, easy to build and do not require skilled laborers. This actually keeps the overall cost of these MSE walls systems low, and typically they're a fraction of the cost of conventional concrete retaining walls. Also, one huge benefit is that these MSE walls are flexible and they can tolerate much larger differential settlements than the conventional retaining walls. There are several different types of MSE walls and slopes that engineers can choose from, depending on the performance requirements. Some of these systems are precast concrete panel walls, Titan earth wall, Stony, Tempest, and Veggie, which are all welded wire form basket walls, Titan earth slope honeycomb, which is a HDPE stacked geocell wall. We have the Titan earth slope grid, which is a 45-degree slope, the Titan earth slope blanket, which is used for slopes less than 35 degrees. And finally, we have soil anchors, which are used for superficial slope stability. Engineers should always consider factors such as site soil conditions, required wall heights, steep and slope angles, water table and seepage, and environmental consideration. Always also remember that, costs, availability of material, and site access always need to be considered. Geogrids are common options for the reinforced element for mechanically stabilized earth systems for several reasons. One is their high strength. Geogrids are typically made of high strength polymers or fibers that can provide a strong and durable reinforcement. Geogrids are resistant to alkaline soils and are UV resistant, which ensures strength and performance. They're flexible and easy to work with and can be cut with a simple tool such as a utility knife. And finally, geogrids are cost effective. These walls and slopes are soil structures. And so therefore, the soil condition of the project site can significantly impact the design of these MSE systems. High groundwater table, rapid drawdown conditions, back-to-back walls, just having marginal foundation soils can be a few challenges that MSE designers need to consider. The other thing is geometry. When dealing with slopes, geometry within a given slope area can be easily overlooked. Varying the slope angle from one station to the next can cause major constructability issues as various MSE systems cannot be easily manipulated and angles cannot be changed. Another aspect that's commonly overlooked is that MSE systems are located too close in proximity to property lines, buildings, utilities, and just other obstructions. This prevents the required geogrid embedment lengths to be installed. We've seen issues where the walls have been designed too high and the bearing capacity of the foundation soils is inadequate to support the structure. There's kind of a misconception out there that the weight of the pressure applied by the MSE structure to the foundation soils can be controlled by the MSE designer. There is slight modifications that the MSE designer can work with to reduce those bearing pressures slightly. But the weight of the soil is unfortunately the weight of the soil. So depending on the height of the wall, that will be the weight of the structure. There are ways to reduce the bearing pressure by using different types of materials like a lightweight fill or even styrofoam. The correct way to deal with these is to remediate the foundation soils to provide the correct bearing capacity to support these structures. Seek advice from a knowledgeable supplier like Titan and allow them to provide a preliminary design. Too many times we see a system specified that doesn't have the correct components, conflicting information, incorrect configurations, and just inconsistencies on the way they've specified these MSE systems. Also, relying on an experienced supplier like Titan can help guide the engineer through the specification process by choosing the correct MSE product. This will minimize delays and help the project stay on budget. Titan also assists contractors with site support to ensure the installer has full understanding of the Titan shop drawings and construction techniques and just the sequencing for proper installation. Also, having a preferred installer that has prior experience and is recommended by Titan can help with saving the contractor time and money on the installation of the MSE system. Geotechnical information directly at the location of the wall is very helpful. Too often than not, we find on site where there are boreholes, but they are so far away from the actual wall itself. Although this is not always possible, this will help mitigate geotechnical surprises on site prior to the installation of the wall and slope systems. What that means is, so when you usually have like a large site, they'll go and at the initial stages, they'll take these borehole where they're just sampling the soil. And so a lot of times there'll be this 2, 3, 4, 5 kilometer section, but they'll take maybe 20 boreholes, and usually it's not in the area of the wall itself. So it's because they're doing bridge structures, they're also doing highways. So, or even like on a site development, they really care about the building structure and not a retaining wall. So they'll take these samples in locations away from the wall, but then you're supposed to use that information to design your wall. So a lot of times it's not directly correlated to the wall and where your wall is sitting. Proper drainage is critical for the long-term performance and stability of MSE walls and slopes. If water is allowed to accumulate behind the wall or slope, it can increase the lateral pressure and reduce its stability. And this can lead to structural damage and even failure. Drainage blankets are a geosynthetic material that is placed directly behind the backfill material to allow water to drain away from the back facing of the wall or slope. The drainage blanket typically consists of a synthetic core that is sandwiched between a geotextile filter fabric. Drainage pipes are also incorporated in. They collect and transport water away from the wall and slope. There's also French drains. A French drain is a type of subdrain system that can be installed along the base of the system. It consists of a perforated pipe that is surrounded by gravel and other porous materials and designed to collect and transport the water away. There are several factors that can threaten the integrity of an MSE wall or slope structure. These include bearing capacity of the soil, which refers to the maximum load that a soil can support without failure. Another factor is drainage. Poorly drained soils can lead to water buildup, which can increase the lateral pressure on MSE structure and reduce its stability. Engineers may need to install a drainage system to manage water runoff and prevent water buildup. Seismic activity, such as earthquakes, can cause the ground to shift and could damage the MSE wall or slope structure. Engineers must carefully evaluate the site condition and select appropriate reinforcing elements and construction techniques to ensure a stable and durable system. Proper construction is also critical for the stability of the MSE wall or slope. Most of the failures that I have seen personally have been from incorrect installations. Regular monitoring of an MSE wall or slope structure can help detect potential issues early on and allow for timely repairs or maintenance. Engineers can use various monitoring techniques such as visual inspection, settlement measurements, and slope inclinometers. Titan Environmental has a wide selection of MSE walls and slopes for many different applications. We do have a dedicated and experienced MSE engineering team, always willing to help with just reviewing the project specifications and requirements and the intentions. We are here to outline the pros and cons of each system and provide recommendations on the best system for the application. Our team can work with consultants, owners to provide a comprehensive technical package consisting of drawings, details, preliminary designs, and just a budgetary cost estimate to just ensure that this MSE wall system that they're specifying remains within the project budget. We can also provide stamp construction drawings, and as the project progresses to the construction phase, can provide initial hands-on assistance to ensure that the installer has a solid grasp of how the MSE system is built. Titan has the engineering expertise to also provide certificates for the MSE system if required by the project specification. It is Titan's objective and goal to provide engineers and contractors with a full turnkey solution from the initial idea to the fully installed MSE product.